So, hi everyone. My name is Gautam. Today I'm going to be giving a presentation on the topic software architecture robustness analysis. So, we all know the term software architecture. So, what is software architecture? Software architecture deals with the overall view of the system or layout of the system. So, software architecture depends on many factors or factors such as reliability, quality, scalability, performance, etc., etc. So even though there are many factors, why are we more concentrating on robustness? So how does robustness affect the quality of software architecture? So in this PPT, I am going to explain in detail what is robustness, what is the characteristics of robustness, and how does robustness affect the quality of architecture by explaining a case study to you all. So before starting the case study, let us all know what is meant by robustness. So, robustness refers to the system's ability to handle unexpected conditions gracefully without crashing and to terminate properly. So, robustness covers uh, five attributes and characteristics, such as handling unexpected conditions. So, robust systems can handle diverse inputs and extreme scenarios like malformed commands or power failures. They should log reasons for failures and terminate gracefully. And user notification. Clear communication of program behavior is crucial, ensuring a robust user experience. Third, adaptability to change. Software, especially social media applications, must adapt to evolving user requirements. So features like alternate login methods require robust design to implement seamlessly. Fourth, stress scenarios. Stress situations like handling Unicode data, large media, concurrency, or network failures can test system robustness. Internal and external faults can lead to system failure, necessitating monitoring and notification tactics. Fault handling. Robust architecture employ mechanisms like exception handling and redundancy to tolerate faults and maintain performance. Monitoring, serialization, and dynamic self-heading mechanisms aid in fault recovery. So now we can see about robustness and other quality attributes. Like there are many quality attributes such as reliability, availability, scalability, etc. So in this, we have taken reliability and availability. And how does robustness and these attributes intersects each other? So reliability. So we all know that reliability means like the long-lasting capacity of the software. So to a software to be long last, we need like robustness should be incorporated with it, um, so that to give better life for the software. So like while reliability ensures consistent output for given inputs, robustness focuses on handling unexpected faults. So if we can minimize the occurrence of faults, the software will have more reliability. So availability. Availability measures a system's uptime within specified bounds. Robustness ensures uninterrupted operations even in the face of unexpected inputs and minimizes downtime. So, now the characteristics of robustness. There are four characteristics of robustness, such as fault handling, productivity, fail-safe behavior, compliance. So, let us discuss in detail what is meant by that. So, fault handling. As we all know that if there are any unexpected errors, robustness uh, is a kind of property which handles it. So systems would maintain performance in the face of unexpected faults through mechanisms like exception handling and redundancy. Productivity. So productivity, robust systems maintain expected output despite adverse conditions. Metrics like learning curve, changes inflicted and fixes can access productivity. Fail-safe behavior. Systems should gracefully transition to alternate states when critical failures occur, ensuring continued operation. Compliance. Robust system adhere to standards and protocols, ensuring architectural compliance. So, till now, we have discussed what is robustness and what are the characteristics of robustness and how does different other attributes incorporate with robustness. Now, uh, we can discuss a case study based on designing a robust automation testing framework to see how robustness affects the quality of the architecture. So, this case study, as I said, designing a robust automation testing framework, um, um, supposed to work and then point out what measures have taken as well as can be taken to stress on robustness of the system requirements. First, we can see what are the requirements for for this case study. So this system works as a common framework for integrating as system testing teams who want to run their test cases targeting a video streaming service platform provider. This platform is already in place with all service provider systems deployed into cloud infrastructure. It should employ a contiguous integration environment to acquire user input and publish results globally accessible servers. So objectives. So the main objectives of the framework is given below, like be platform independent, calculate and report test execution time, support continuous integrations for immediate availability of new test cases, enable agile methodology with traceability of functionalities to requirements, scale to handle increasing devices and services, ensures portability and backward compatibility during upgrades, handle test execution order and about these records on failures. So these are some objectives of the framework which should be followed. Also, uh, the frame also the operations have to be the given below operations have to be followed in specified order. So if one test case fails, the whole system comes out of the framework and stops its execution, which gives the which incorporates the robustness. So the order of actions is given below. Like there are 12 sequence of actions which should be followed in order to ensure the correct testing of framework. So the entire process is being automated. There is no scope of manual altering result files. So if a test case fails, the client will be able to see in the reports. This directly impacts business and future economic prospect of the project. Therefore, it is imperative that the system designed is very robust way. If there is any issue in the system, it is the failure of the entire system. So till now, up to this, we have seen about the frameworks and uh, how does the framework work? How does the framework works? So now we can incorporate this framework with the different architectural patterns we have, and how does robustness incorporate with that architectural patterns. So below this table gives us an idea how some prominent patterns uh, implementing architecture for our case study requirements with an eye for implementing robustness. So architectural side. So layered architecture. Layer architecture is used to add levels of abstraction by dividing into systems into submodules. So in our project, if we club all modules together, it will be difficult to keep track of information. So in this, modules are grouped based on similar tags, which helps to identify and fix the bugs easily. Also, it can handle faults efficiently and provide and point out which subtask error is generated. So next, pipe filter architecture. Pipe filter architecture is used when one process provides some output which can be used as an input for other process. Like the sequential order which is shown below. Like in this framework, the order of execution is important. So if we execute in an irregular, improper order, or if we try to execute uh, more number of steps parallelly, it may generate error. Uh, which leads in an unstable state. To avoid this, pipe filter architecture is used. Also, it can be used for exceptional handling, but not for redundancy of resources. Then, um, publish subscriber architecture. Public subscriber architecture follows a principle of get what you need. So, as we all know, publish keep tracks of subscribers and provide necessary services to them. In our case study, there are multiple ways test results can be published, such as JSON, remote file server, ELK server, MongoDB. Based on the selection of user, publisher provides services to them, which ensures exception handling. Then MVC. MVC stands for Model View Controller. As we all know, model is used for identifying the business logics, and view is used for uh, used to give interface to the users, and controller regulates the behavior of the model. So this MVC pattern gives us privilege to see if there is any leak of the breach of the protocol. Controller gives us a way to handle faults and isolate them. If the if the controller finds which process is giving error, we can separate the process, and we can find an alternate solution for them. Then last, microservices. Microservices is a new type of architecture in which uh, similar activities are grouped together and provide self-sufficient components useful for supporting various range of platform desired. Deployed services independently to target diverse platform and cloud environments, facilitated easy scalability, fault tolerance, and automated instance restarts in case of failures. So now we have discussed uh, how does these patterns helps in for the robustness of the architecture. Though future work and conclusion, future work could explore formal methods or architectural description languages for handling exceptions at elevated level of abstraction, quantifying core characteristics of robustness and comparing them after additional measures can further enhance the system resilience. Continuous improvement in architecture design and implementation is essential for building robust software systems with longevity and reliability. By adhering to robust design principles and leverage architectural patterns, the automation testing framework ensures seamless execution, accurate reporting, and scalability to meet evolving requirements. Thank you.